Okay. Good evening, everyone. So, the I am Dr. Subhanan Supari, Assistant Professor in EEE in Sambalpur University Institute of Information Technology, Billa, Odisha. So, basically, here we are going to conduct a series of going to provide a series of videos in which some basic experiments of our electronics lab in SUIT Gulla has been recorded and the practice will be done over here. So the first experiment here is to study the R and RC firing circuit of SCR. All of you know SCR is a silicon control rectifier. So here that you have a design example. This is R triggering circuit. So you have to design a R triggering circuit for a half wave control rectifier for circuit for 24 volt RMS AC supply. The SCR to be used has the following data. The minimum gate current is 0.1 milliampere. The maximum gate current is 12 milliampere. The minimum gate voltage is zero point 0.6 volt and the maximum gate voltage is 1.5 volt. So basically here is the circuit. This is R firing circuit. Nowadays these circuits are obsolete in nature. But here you have a SCR. This is a three terminal anode, cathode and gate. And here you have a diode because this is a R firing circuit. You have only the load is a AC load and R firing circuits R1, R2 is a potentiometer or a variable resistor and R. So you have a R1, R2 and R. The VM is the peak voltage is 24 into root 2. The R1 should be greater than VM divided by Ig max. So you are getting 2.8 into 10 raised to power minus 3 ohm, but the nearest value is 3.3 kilo ohm. The formula here R is less than Vg max into R1 divided by Vm minus Vg max. So it is 120 ohm and R2 is Vm minus Vg mean divided by R into Vg mean minus of R1. So here R2 equal to 3.37 into 10 raised 3.37 kilo ohm. So you have got R1, R2 and R, the values of R1, R2 and R. Now we are going to simulate this particular circuit with the help of multisim. This will be the circuit and the resultant waveform. So let's start with the simulation. Here we have a multisim. I am using multisim 11. So click over here the power sources. So it will be AC power. The AC power I will put over here and obviously I will put a ground over here and then I will double click on this AC power. The voltage RMS is 24 volt RMS. The 50 hertz is the frequency. Okay, I connect it around here. The next circuit is a three resistors or two resistors basically. I choose any of the resistors over here to register, and third one is a variable resistor. Here you can get a potentiometer over here, and there will be a diode. Select all groups, and we have a diode. I can choose any of the diode I14007 or IN4149. 4149 is a the turn on and turn off time are little bit higher, so I choose a 4149. If I do a control R, it will be connected. It will be rotated over here. Control R is the symbol for rotation. Then I connect place all these circuits, place all the components over here, and I connect it over here, all the components. Then you can see over here you can place a component here, and then choose a SCR, go to source, select all groups, and you can choose a SCR basically. Any SCR you can choose 215064 any SCR. The specification of the SCR can be obtained from the datasheet, and I require a load. The load can be going to the lamp, the all groups, and here you are getting a LED lamp because it's a 24 volt. Let's uh, take around 28 volt or 24 volt or even 7.5 watt. Let's take it here and let's connect it. Let's connect it over here, and we will place this across here, and it is relatively easy to construct a circuit using multisim. And then we will put the values, that is R1 is 3.3K. So let's write over here 3.3K. The potentiometer is 120 ohm. The potentiometer is again 120 ohm, and this is again 3.3K. Or let's just a minute. For 3.3K is R2. So this will be 3.3K or 4.7K R2, and here it will be R2 will be 120 ohm. Now let's get a oscilloscope across here, and in use list we have used previously used a ground. So let's connect a ground, and let's first check whether our input or input signal is coming. Let's double click over here and auto set, and just figure it out. So you can see the input signal that is coming. You can measure the input signal. Channel 1 type frequency is 50 Hz, and the peak to peak is little bit higher, 67.8. Let's we'll check it out what is wrong over here. And then you can check the diode or the SCR and second waveform. Just check it out. Here we can change the, and here you can see there's a change in voltage over change in the voltage output, and you can see over here the light is also changing over here. So here you can see that the bulb is glowing over here with the change in variac. So this particular SCR is used for a phase control. This is a circuit for phase control of SCR, and this particular AC load, that is 28 volt 7.5, that is changing over the values that were changing with the help of this SCR, and here you are getting the actual SCR over here. So you can take a snapshot over it, and this is the input waveform, and this is the thyristor voltage. You are getting the thyristor voltage across here, and this is basically the RRC wiring circuit for a SCR. And here you can also measure the channel 2. Channel 2 also you can measure the frequency, the mean, the peak to peak, whatever it is there, you can measure the channel 1 and as well as channel 2. And you can stop the simulation. So that's all about a RRC firings.